Yeah, so let us begin. So let me okay. Yeah, so in the previous session we saw the use of atomic barriers. We also saw loop carrier dependencies that are there in our OpenMP code, which you can encounter, which we can encounter while parallelizing the for loops. And yeah, we saw atomics, barriers, and then we saw a few clause, right? Like default, shared, private, and so on. And towards the end, we also saw a few miscellaneous clause like master, then single, and so on. If clause we saw. So that was the quite a brief overview for the previous session. So in the today's session, we are going to look deeper into a few other clause. So we'll revisit this shared, default, and private clause, and then we'll look into few other clause like Firstprivate, Lastprivate, and so on. Yeah, so with this, let us start our today's session. So yeah, we saw this slide, right? So just for the recap, we'll quickly look into what are this private, shared, and default clause quickly. So we saw this, right? That if we specify something as private, then each thread, I mean, if we specify the private clause in hash pragma on the parallel or parallel for, then each thread will get its own instance of variable or variables based on the number we have specified, number of variables we have specified. And the syntax was quite simple, right? We write hash pragma MP parallel for, and then we specify this private clause, right? So quickly going back to our example where I was sharing this, right? So this was the example that we were seeing last time. So here, if you remember, right, that we wrote this thing private. So this ensures that each of the thread will have the private copy of J. And yeah, in that way, we were able to eliminate the data arrays in this code. So this is the syntax for private. And one more thing to remember with this private clause is that it can be a resource consuming operation, because let me share my whiteboard. So quickly, I'll explain that. So, okay, I cannot see my whiteboard somehow. Just let me quickly. Okay, just a minute. Share. We saw this, right? This syntax for the private class, right? Hash pragma OMP parallel for, followed by let us say private J, right? We wrote this. So this can be a resource consuming operation, because let us say instead of J, we specify something else, right? We specify some array A. Now this array can be of a very huge size, right? So let us say you have some sorry, some array like this. Array of integer of size 1000 cross 1000 cross 1000. So if you have such array, then if you see, let us say that integer is of 4 bytes, and you have dimensions are 10 cross 3 into 10 cross 3 to 10 cross 3, right? Sorry, 10 power 3 into 10 power 3 into 10 power 3, right? So if you see, this can easily turn out to some 4 GB. And whenever this statement is hit before this loop or something like that, for loop, then each thread will get its own copy of this variable. In this case, it's array A. So each thread will have the private copy for this array, which is a 4 GB. And if you see this, then it will turn out to be 4 into, let's say, your 10 threads, then 4 into 10, which is 40 GB of data, right? So 40 GB of data can be consumed. 40 GB of RAM can be consumed actually, because everything, these variables and all those things will be in the RAM. So it can be resource consuming. So you have to use it judicially. So you have to use it where it is needed, but you have to use it judicially. And apart from that, one more point for this private clause is that let us look at more visually. So what will happen is that this is your RAM, right? And let us say this is your process P0, which is some OpenMP process that we are running. So whenever this statement is encountered, this hash pragma parallel for private, let us say J, private J, then what will happen is that let us say that OpenMP forks 4 threads. Then in that case, you'll have this 4 threads, right? T1, T2, T3, T4. And whenever this statement is encountered, and when OpenMP compilers, I mean OpenMP part of the compiler see this private A, what it will do is that let us say there was some key, let us say stack, in which there was this variable A. Now what it will do is it will create the copy of this variable A on each of these thread, right? And the initial value will be undefined, right, for each of this. So we saw this example, if you remember. Let me quickly share that. So if you remember, we saw this example as well, right? This one where we were trying to figure out the value of J inside this parallel for region after making J as private. But we were observing that even if J is set as 1, we were getting 0 inside. So the point here is that uh, value will be undefined for each of this, right? So we need to explicitly specify the initial value when we specify a variable as private, like this variable or some array or something like that. Okay, so let us quickly move back to the slides. Yeah, so as I said, each thread will have its own instance of variable, and this is the syntax we have gone through this. And initial value must be specified in this case of private clause, and it can be the resource consuming, since each thread will have the private copy. So we saw the example for that also, right? So moving ahead, we saw this thing, right? So quickly recapping this. So for the shared clause, again, if we specify a variable as shared using the syntax, so let me quickly go back. Yeah, here. So let us say that you want to specify this N and A as shared, then this is the syntax, right? So we are using shared clause here. And since we are defining A and N as shared, so each thread will not have its own private copy here. So this will happen in this case. Let me quickly share my whiteboard again. So what will happen in this case is that each thread, so again, this is our RAM. And this was our process P0. And this statement was encountered, right? Okay, I think, yeah. Okay, so the statement was encountered, right? Hash pragma P parallel followed by shared A and N. Let us say that A and N were two variables. So what will happen is that when the statement is encountered, there are, let's say, 4 threads that are forked by the master thread, which is our P0. And now this A and N are already residing in this master thread, right? In somewhere stack or heap somewhere. Now what will happen is that each thread won't get the separate copy. So they'll use this copy which is there inside the process or master thread. So that is what will happen when the statement is encountered. So that is all about the shared variables. And in this case, this is not a resource consuming operation because we are just not creating any copies within these threads. But one thing to note here is that there can be data arrays, right? There can be data arrays when we try to access this variables A and N, and we need to make sure that this is handled. So for that, we learned multiple things like barriers and barriers critical, right? Critical and atomics and so on. Right. So this is the word for the shared, and now let us look into the last one which we saw last time. Just to recap quickly, was the default one, right? So in case of default, we use it for specifying the behavior for the unscoped variables in our program. So if you remember, let us quickly go back to our this program where we were looking this thing, right? Save this and yeah. So we specified this default as shared, right? So what default as shared does is that it will specify the scope of all the undefined, unscoped variable as shared. So all this J, N, and A are by implicitly will be shared variables. And after that, we can also specify explicitly the scope of other variables. Like let's say we want to make J as private, then we can specify it here. So shared will make the unscoped variable as shared by default, and similarly we saw none, right? So none will make it, so none will say that it's programmer's responsibility to define the scope of each of the unscoped variables. So in that case, apart from this, like making J private, we need to also specify shared and right. So since there are three unscoped variables, we need to specify the scope for each of them, and that is what we are doing here. Okay, that is what we saw for default. Now let us quickly go back to our slides. Yeah, so okay, before that, let us quickly look into this also. So this is clear, right? Shared, default, and private. Now let us come to this example itself, right? So here we were facing the issue, right? The issue was that this variable J was, since we declared it as private, it was, it was getting these values. Each thread was having the private copy of the variable J, but each thread was having the default value as unspecified. So this is the issue, right? So quickly, if I run this program, if you remember, let me quickly run this as well. So if I run this being G++, right? So when I run it with yeah, so what we saw was like all the values were zero, like all the private copy for each, the J will have the private copy for each thread, and those were initialized, not initialized, but those were zeros, right? While if you remember here, here the default, the initial value that we set was 1. So there might be a scenario where we actually would like to copy the initial value, which is there for a variable, into the private copy for each thread, right? So let us say that before this loop begins, execution of this loop begin, we want to copy the initial value of J, which is 1 here. So in that case, what we can do is we can use this clause, which is Firstprivate. So what Firstprivate will do is that it will specify each, specify this variable J, each of the variable that are mentioned inside. In this case, it's J. It will specify J as private. So each thread will have its private copy of J, just like the private clause. But apart from that, what it will do is that it will copy the initial values. So in this case, the initial value of J is 1. So whatever the value of J is before this this pragma statement, it will copy that value of J inside the private copy for each variable. So if you try running this program, let us try it. Yeah, so let us try running this program again. So okay, let me first make this more clear. So it will copy the value of J into each of the private copies. So here ideally, after doing Firstprivate, we should get the value as 1 instead of 0, because that's the initial value, and that is the value that is being copied to each private copy. So ideally, after doing this Firstprivate, we should assume, we should expect the value to be 1 for each thread. So let us quickly verify that by running our code again. Right. So let us recompile it and run it. So yeah, right, we can say it. Now it's all 1. So essentially what Firstprivate does in this case is that it will create the private copy like private clause, and it will also copy the value for the variable for which we have created the private copy. So that is what is the Firstprivate clause. Let me go back to the slides again. Yeah, so this is what is the Firstprivate. So private clause takes the default values, undefined values as the default values. Undefined values as default values in case of private, but let us say that we don't want the undefined values. We want the values that were pre-calculated within our serial code. Then in that case, we can use the Firstprivate. And what Firstprivate will do is that it will copy the variable's original value in each thread's private variable. That is what we saw right in that program. And yeah, one more important point is that if you define your variable as Firstprivate, then you don't need to define it as private again. So if you remember here, yeah, in the code, we just defined JS private and Firstprivate, and we didn't wrote this thing right after that private J. So just saying that it's a Firstprivate will ensure that it's a private also, and yeah, that is what it is. So it will be private plus it will copy the initial value. So that is what is the functionality. So now quickly going back, yeah, so again, it can be a very resource consuming operation as we discussed, resource consuming as well as time consuming in this case. So yeah, so let us come to this point here, right? So you have this hash pragma OMP parallel for, and then you have Firstprivate, right? And you're specifying the list of variables, let's say A, B. I'm putting some random variables here. So these A and B can be arrays as well, right? So what will happen is that, let us say that A is some array again of dimensions 1000 cross 1000 cross 1000. In this case, again, as we saw, let us say it's an integer array. In that case, again, the size will be 4 into 10 power 9, right? Which is 4 GB. Now, in case of Firstprivate, we are not just creating the private copy, we are also copying the data, initial data into each thread's private copy. So in this case, what will happen is that each thread will have not just private copies. So this is the private copy. This is the resource consuming operation, right? That each thread should have a private copy. So there is this 4 GB of memory that's getting allocated for each thread. Apart from that, there is the initial copy operation also that is happening. So that thing is time consuming, right? Copy values. So copying of values is again the second thing that happens in case of Firstprivate. So that is what makes this Firstprivate not only resource consuming but time consuming also. So you should use it with care. So there are cases where you need to use it, but yeah, we should avoid where it can be avoided. So yeah, this is about Firstprivate, and again coming to our visual representation. Again, let us say that 4 threads are being forked: T1, T2, T3, and T4, right? And this is process P0. So what will happen is that, let us say that there were 2 variables A and B here with the value 1 and 2, let's say. Then in this case, what will happen is that not only the separate copies will be made here for each thread, but those initial values of 1 and 2 will also be copied here. So that is what will happen in this case. And I hope that the example that I gave in the previous code that we discussed was helpful in visualizing this thing. So, okay, so this is about Firstprivate. This is done. Now let us go back to our example code. Yeah. Okay, now let us look into this code. Yeah, this code. I request each and every one of you to try what will be the output for this code. So just quickly going through this code, what we are doing here is that we are initially setting J as 1 and N as 10 as we did for our previous example. Then we are writing the value of J. Then we are using this hash OpenMP parallel for with 10 threads we are launching here. I mean, we are doing work sharing of this loop with 10 threads. And again, we have declared J as private. Then we are doing some setting. I mean, we are setting the values for J, and then we are again printing. So request everyone to predict the output of this program. I mean, what will the output of for this program? I'll wait for a few seconds here and then we can discuss. So we just want to know the output for this program.
So the original value of j should get printed.
Original value of j should get printed where there are two printfs, I mean couts that are happening. In both the case or just which case?
So in both the cases, the original should get printed because j in the thread block, the j is being taken as a private. So the private copies are getting modified inside the thread block.
Yeah. Any other suggestions? Anyone thinks that whatever we are setting here might get printed here? Anyone? Okay. Yeah, if there are no suggestions, then let us try to understand this code. So basically, we are printing the value of j. So this should be clear, right? This part is serial. So here we are setting j as 1 and then printing j. So this should be 1 for sure. Like this is the serial part, and we shouldn't have any doubt for this. So 1 should be printed here. Now coming to this part, we are making j as private, and then we are doing some for loop here in which we are setting the value for j, and after that we are printing j. So the point here is that will setting of this j value inside the parallel region while j being private will affect the value of j here, which is outside. I mean, point here is that whether j will be 1 or something else, 2 or 3. So for understanding that, let us go back to our whiteboard example that we saw previously. So, right, in this case, if you remember, sorry, not this one. Yeah, this one. So this was the example for a case where variable a was private, right? In this case, in our case now, we have j as private, right? So whenever this parallel or parallel for region is terminated, this parallel region is terminated here, all the private copies get destroyed. So essentially what will happen in our case here, it's a j instead of a, right? So all these are j. There are private copies of j here in this case. Now j was 1, then we were doing some operation, and then we were coming out of this parallel for region here, and then we were printing j, right? So what will happen is that here at the end of the parallel region, the threads are the threads are offloaded and all the private copies are destroyed. So essentially what will happen is that again, whatever was the initial value of j, that will be printed. So 1 will be printed in this case. So let us quickly confirm our observation here quickly. So by running this program, so let me save this and quickly go to my shell. Yeah. So this was coding 3, and if you run this, and if you see, it is 1, right? Both of them are 1. So I hope you're getting this. That here, if I go back here, both of these values of j here are 1. Now let us say that your computation is such that after doing this for loop computation, right? You want the value of j which was there inside this loop. The value of j that was calculated at the end of this loop to be copied back to the original j variable, right? In the master thread. Then in that case, what you can do is that you can use this clause, which is Lastprivate. So doing j as Lastprivate or any variable as Lastprivate or any array as Lastprivate, what it will ensure is that whatever the last value for that variable j was there, it will be copied back to the original variable in the master thread. Now, when I say last, it is the last value of j, provided that this loop, last value of j for the case where this loop was ran in serial. So whatever the value of j would have been there when this loop would have been run in serial, the same value will be copied back to the variable j when I make it as Lastprivate, and that will be displayed here. So that is what is the point. Now tell me the output of this program. What should be the output of this program? This is one for sure that we are not worried about. What will be the output here now? It will be 2 or 3, or still it will be 1 or 2 or 3. Anyone quickly would like to comment?
So it should be 3.
Okay. Anyone else who would like to add anything like 2 or 1? If anyone else would like to go with that option. Okay, yeah, so that is correct. It should be 3 because if we ran this loop in serial, in case where we run this loop in serial, the value of j that will be set will be 3, right? So the output should be 3 in this case. So let us confirm that quickly. Yeah. Let me go back to my yeah. So now it is 1 and 3. So this is concurrent with our understanding, right? That it should be 3 now after the Lastprivate, setting that JS Lastprivate. Now let us say that I want to tweak this code a bit. So let me go back to the code. Now instead of parallel for, let's say make it as parallel, right? Now what will happen? Let us say that I make it as private. Sorry, yeah. So let us say that I make it as Lastprivate, JS Lastprivate, along with hash pragma OMP parallel. So initially it was parallel for, now it's parallel. So what will be the value of j now? The one that will be printed here. Anyone would like to comment on this?
So it should still be 3.
Any other thoughts apart from 3?
Sometimes it will vary. It's based on the, since we said parallel, sometimes the fifth thread may be the last one where j may be set to 2. Sometimes we will get the value as 2 also.
Okay, so let us say that I do this TID equals to OMP get thread, sorry, thread number. And let us say that I do this j equals to TID. Anyone to comment on key what will be the output? Will it be anything from 0 to 9 or something else? Anyone would like to go guess what will be the output?
So it should be something from 0 to 9, but the output the output can't be predicted.
Okay. Yeah, so no output can be printed because we are doing it as Lastprivate, but the issue is that yeah, so let us try running this. So issue is that this program will not compile. So let us try running this. It is giving the error, right? What error it is giving? That Lastprivate is not valid for our hash pragma in the parallel for. So the issue here is that if I go back to the code, that this hash pragma, this Lastprivate clause is not applicable to hash pragma MP4. So this is the important point you should know. So not every clause will be applicable to all the directives. So in this case, directive is parallel and clause is Lastprivate. So this Lastprivate can only be applicable to the parallel for directive. And why is that the case? Because In case of parallel, you can't predict what will be the output of the serial code, right? Let us say that I ran this code, ran this code in serial. Then you can predict the output as some specified value. But when you run this code in parallel using, let's say, 5 threads or 10 threads, you don't know what will be the value of J. So there is some level of non-determinism that is involved. And since what Lastprivate say is that I'll copy the last value that is set. In this case, the last value that is set itself is non-deterministic, right? So ideally, Lastprivate will not work with #OpenMP parallel. It will only work with for and parallel for. So that is what the point that I was trying to derive here.
Just am I audible?
Yeah, yeah. Please go ahead.
Even though it is the thread cannot be determined, it can be dynamically it can be done, right? But the compiler is looking for the statical. That is why it is not. It is giving error.
Yeah. So the point is that Lastprivate is designed in such a way that it won't. It won't allow the parallel part to work with it. So it will only work with the loops or something like that, where the output can be some deterministic or something like that. So yeah, you are correct in that way that it is looking for some static part. Okay, so quickly going back to our visual representation. So in this case, apart from J being, so J will be, undefined value initially in case of Lastprivate also. So when we define J as Lastprivate, the initial value for each of the private copy of J will be non-deterministic only. But the point is that these, whatever with the final value, let's say for some threads it's 2 and another, for others it's 3, then whatever the last value is there, in case of, for the case where the code was ran serially, it will be copied back to the original variable, right? So this will be made 3. That is what we saw, right? So this is what is the Lastprivate. Let me quickly go back to my slides. Yeah, so I think we covered all the points, right? Or not for this, for the Lastprivate. So it provides the superset of the functionality provided by private clause, because apart from making private copy, it also copies back the last values. And yeah, this we saw, right? We copies from original value upon exit from parallel block are copied back. And yeah, the syntax is, as we saw, Lastprivate followed by the set of variables that you want to specify. And the important point is that it is only applicable for and parallel for. Yeah, I think that is all. Yeah, so let us now quickly
So
look
I have
into.
one doubt
Sir?
about the last private clause.
Yeah.
So since the value that's being written to the private variable is the one that's executed on the last iteration of the for loop, so is
Yeah.
it guaranteed that the last iteration or the thread executing the last iteration is the one that's executed after all the threads?
Sorry, can you repeat? I missed that. Sorry, can you repeat your question?
So for example, if we are running a loop from 0 to 9, right, for 10 variables,
Mhm.
so the value that's being written to J is the one that's coming as a final output in for the for the value where I is equal to 9, right?
Mhm.
So is it necessary that the thread executing the I is equal to 9 iteration is the one that is being executed the last, and all the other threads have to be executed before that?
I don't think so. So still that functionality of all threads running and all iterations being distributed the work among other threads, all the threads will be still be preserved. But what OpenMP does internally is that it determines the, I think what it does is that it will determine uh, the thread which will execute the last iteration, and based on that, it will copy back the value from that thread. So that is what will happen. I don't think that it does some synchronization or serialization, some kind of that the last thread writing will do that operation last or something like that. I
Okay,
hope
so
that they answered your question. Okay. Okay. Let me know if there was some confusion or anything like that. Yeah, but let us go ahead. So the next clause that I want to discuss is, no, I think we'll discuss some runtime libraries before discussing the next clause. So just two runtime libraries, extra runtime libraries that I want to add here at this point before moving ahead is OMP set dynamic and OMP get dynamic. So let us see what they are. So uh, when I do this, right? If you remember, the runtime libraries are like the functions, right? That we are using to instruct the OpenMP part of compiler to set something or get some data from the environment. So if you remember our first or second session, during that we discussed about runtime libraries. And we discussed three of them so far, right? One was OMP get num threads and set num threads, if I'm not wrong. These three were the at least three that we were discussed. So at this point, I would like to add two more. One is OMP set dynamic and OMP get dynamic. So what essentially they do is that when I do this, right? Okay, let me go back to my whiteboard again. So okay, this one, okay, let me use this one. Yeah, so when I do this, right, OMP set dynamic, and give it the true as argument. So what it will do is that it will enable dynamic threading. And what I mean by dynamic threading is that so during execution of parallel for region, OpenMP part of the compiler, what it can do is that based on the availability of resource and the optimal work sharing or something like that, what it will do is that it will change the number of threads. So let us say that you have this hash pragma OMP parallel for, let's say, and you haven't specified any number of threads that you want to run this parallel for with. So what OpenMP might do is that it might launch this with, so it might look into the for loop and it might launch this region with, let's say, 6 threads. And let us say that you have another hash pragma OMP parallel for, right? And based on the loop that is followed by OpenMP might determine that it will be better that I'll run this uh, parallel for with, let's say, 10 threads. So it can dynamically vary the number of threads, right? So that is what it ensures this OpenMP set dynamic. And you can even set the set the number of threads using hash pragma OMP set num threads. And let us say that you set the number of threads as 10. In that case, it will take the 10 as the maximum number of threads, and it will ensure that the number of threads it is varying dynamically doesn't go beyond this number 10. So that is what is OMP set dynamic. And if you set it as false, what will happen is that it will keep the number of threads as constant. So let us say that at some point in code or somewhere you at the beginning, if you set the hash pragma OMP set dynamic as false, then each parallel as well as parallel for region will have it will run the parallel as well as parallel for region, all of them with the same number of threads. So that is what is the OMP set dynamic. And the another variation is OMP get dynamic. So this one is quite simple. So it is just used for querying the so it doesn't take any argument. It will just return the integer variable based on, so it will return either 0 or 1. So it will return 0 if dynamic threading is enabled, else if it is disabled, else it will return 1. So these are the two runtime runtime library functions that I wanted to discuss quickly here. So okay, let me go back. Okay. Yeah. So that is what I discussed, right? Is written in this slide. So OpenMP, OMP set dynamic will enable or disable the dynamic adjustment of the number of threads available for the execution of the subsequent parallel region. So at some point in the code, you can specify this OMP set dynamic is true, and it will based on that it will enable the dynamic program. If you set it as false, it will disable it. And if set, it will instruct OpenMP to choose the optimal number of threads for parallel for and for directives. And yeah, this is the format, right? We saw like it returns nothing. It returns void, and it takes the dynamic number of threads that you want to set here. And so I think this one is the upper bound, if I'm not wrong, but I need to check this one if I might be wrong here. But yeah, I think this dynamic threads, if you specify here, the number of threads that you specify here is the upper bound that we want to set. And again, OMP get dynamic is for determining whether the dynamic threading is enabled or not, and it returns the integer, which is the which has the value either 0 or 1 based on dynamic threading is enabled or not. So okay, feel free to pause me if there are any questions, but I'll move ahead from here. Yeah, now let us look into another clause, which is Threadprivate clause. So yeah, let us come to this clause. So what this clause does is that it will do the some kind of global declaration for global declaration of variable or variables for all the thread across all the parallel regions. So let us try to understand this with the example. So let me go back to my whiteboard. Let me go back to the page. So let us say that you have a parallel region, right? Hash pragma OMP. Parallel, right? So you have this parallel region followed by you have some another parallel region. Right. So let us say that your computation is such that you are setting some value of some variable here. Let's say A, you are setting 1, X, you are setting 2, and so on. Let's say that you have just 2 variables and you are setting it in the this parallel region, the parallel region 1. Now, let us say that you want to access this same values within the same values of A and X within this parallel region in this second parallel region, right? And let us say that A and X are even private, like these are not public. So A and you have defined A and X as private, right? So these are private. Now, in this case, after the end of this parallel region right here, the value of A and X will be undefined as we saw. We can use Lastprivate, but yeah, if you use private, it will be undefined. But let us say that you want to access them here in the second parallel region. And let's say you have also few more parallel region beyond this, right? And you want to access these values of A and X across all the parallel regions. Then in that case, what you can do is that you can specify this A and X as Threadprivate. So what you can do is that if I come to the syntax part in the next page, let me use next page. So you can do this hash pragma OMP Threadprivate A and X. So this will ensure that there will be a private copy for each parallel region, and that will be persisted. So the private copy for this A and X will be persisted across all the parallel region along with the values. So private copy as well as the values will be persisted. So that is what is the Threadprivate. And one more point to note here is that this Threadprivate will come much before or much ahead of any parallel or parallel for region. So this might not be inside the parallel region. This can be well outside the parallel region within the serial region. So this can be in the serial region where you are defining that I want this A and X as thread private. And yeah, so essentially it will persist the copy as well as the values for this A and X across all the parallel regions. So let me go back to the slides quickly. Right. So yeah, as I mentioned, right, you can use this immediately following the variable declaration. Not necessarily, I mean, it should not be within the parallel region, because essentially it is saying that it needs it needs the values to be persist across the parallel region. So its declaration can be well above the parallel region or just after the variable declaration. So what essentially it will do is that it will keep the variables allocated for thread across the parallel region and will retain the computed values and local copies of each thread within the local copies of each thread. And we saw the syntax, right? Hash pragma MP thread private, and then the set of variables. And yeah, this is where one important point that I want to mention, that we need to disable the dynamic threading if you want to use the thread private clause, because you can see the problem, right? If the dynamic threading is on, then let us say that let me go back to the whiteboard. So let us say that we are here, right? This case. So let us say that this parallel region, or let's say this was the parallel for region, then it might be executed by 6 threads, and then this parallel region might be executed by 4 threads. So in that case, we have variable number of threads executing different parallel regions. So what will happen if dynamic threading is on is that there can be a different number of threads executing each parallel or parallel for region. And in that case, it would be, it will not be possible to define the private copy and just keep on changing it. So in this case, what thread private need is that dynamic threading should be off, so that each parallel or parallel for region will be executed with the same number of threads. So that it can maintain the private copy for each of them and make sure that the values are preserved across all the parallel regions. So okay, I'll maybe pause here for a minute to take any questions, maybe if you have any.
I have a question.
Yeah.
Can you go back to the previous slide, whiteboard? To explain this, you used some whiteboard, right?
Yeah. Sorry. There's one.
Not this one, the next one.
Okay.
Persisted in the sense, these variables will be kept in the heap of the process where we create the threads, or it will be written into hard disk or some secondary storage.
I don't think that it will be written in hard disk. It will be there within the heap of the process, as well as there will be a private copy as well, right? We are declaring as thread private. So there will be a private copy as well as there will be some there will be a copy in the heap for our process, but it will make sure that the values as well as copy, the copy is persisted as well as the value is consistent. So that is what it will ensure. It will definitely not write it to the hard disk. That is for sure.
One constraint is that we cannot have variable number of threads, right?
Yes. Yes.
Okay.
Okay. Any other questions? I'll wait again for some time. I think there is something in chat. So someone is saying that thread private is working same as Firstprivate. No. There is a subtle difference, right? So let us say that, okay, let me go back here. So in Threadprivate, what was happening? If you remember in Threadprivate, what we were doing. So let us say that there was a value of j, right? So let us say here, instead of a and x, I declare the same variable as Threadprivate. So in case of let's say I declared this J as first private in parallel for, right? Then it will copy the initial values. But after this parallel for is finished here, it will again have undefined values. But this thread private, what it will do is it will even persist those values beyond that. So that is what is the difference. I hope I made it clear. So there is a difference between first private and thread private. Okay. I hope this is clear. If there are any questions, then please feel free to ask, because yeah, I mean, we might be using this in our upcoming example. So yeah. Okay. If there are no questions, then okay, I think we have covered this slide. Yeah. Now let me go back to my code screen, and let us look into this code now. So this is a very simple code demonstrating the example of thread private class, and we'll look into this example. So there are 2-3 points that I want to derive. I think 1 or 2 points. So yeah, this is the main function. Rest all is okay. We have this a, b, I, and t, id as global variables. X is again a float, which is global. We have defined a and x as thread private, right? And yeah, so and then we have set this dynamic threading as 0, means that we are disabling the dynamic threading, and then we have this first parallel region here, followed by a second parallel region here. So quickly look into this code. So this is commented for now, but this is the main part of the code. Quickly look into this code and let me know what will be the output for this code. So apart from declaration of variable here, we are doing nothing. And we have declared a, b, I, and t, id, and x. And here we are just, the main part is this, where we are doing some computation here. So let me know what your thoughts are, what will be the output here. We'll wait here for a few seconds or a minute maybe, and then we can discuss.
How many threads we are creating? I'm not sure.
Yeah, so in this case, since dynamic threading is off, and since we are using parallel, I think it will take 4 threads, because my system has 4 cores. Any suggestions, or anyone who would like to comment what will be the output?
So in the first parallel region, it should take a b x based on the current thread value and
Okay.
print accordingly.
Hmm.
So a and b will be equal to tid and x will be equal to that whatever the TID and the expression value is. And in the
Here,
second one, since only TID is private, TID will be the current TID, but AB should take from the main thread. And you show main
main
thread
thread,
value.
main thread, where, okay, main thread,
Yeah,
okay, from serial part.
I think yeah,
So
it
what will
is.
be the value of AB in, uh, sorry, please go ahead.
No, I mean, are they initialized above somewhere A and B?
No, they aren't. So we are just declaring declaring them as global, and then we are just using them
Think
here,
then
setting here, and then using here.
some uh,
So in the second
A
parallel
can be
region,
taken from the last. Sorry,
Yeah, one
so
at a
in the
time, please.
second parallel
yeah.
region, TID should be TID and value of A should be same because A was also the TID in the first execution. The variable B should be what I think 0 because it's declared in the global scope, and X should be a pattern of 1, 3, 5, and like consecutive odd numbers.
Yes. So
Sorry, in
anyone who
second
disagrees?
case,
Yeah,
I
please go ahead.
feel that TID, like whatever be the current TID of that thread, A
Hmm.
should be the whatever last executed TID of the previous parallel region, like previous parallel structure. Whatever was the last A that happened would be continued here because A was not
Hmm.
private in the previous part. And for B, this time it is not private, but previously it was private. So B should get the global value, which was I think garbage value. And X again, previously it was not private. So whatever last evaluated value of X was there, it should be here also. It
Okay.
depends on the last executed previous thread, like thread from the previous parallel region.
Okay. Yeah. Yeah, I think you are getting correctly. Let us try running this one. So let us go back to, yeah. So let us try running this one. Uh, right. So what it is giving is that, so if you remember from our code, we were setting A, B, and X. So A and B were set based on TID. So 0, 1, 2, 3, since we are launching it with 4 threads by default, my CPU, I mean, I have 4 core CPU. So it will launch both the regions with 4 cores. And as we have turned off the dynamic threading for both the regions, it will be 4 threads. For first region, A, B, and X are, sorry, A and B are set based on TID. So A and B will be 1, 2, 3, respectively 0, 1, 2, 3. And X will be 2 into 3, 2 into TID plus 1. So it will be 5, 1. So it will basically odd numbers, right? 2 into TID plus 1 is nothing but it is generating the set of odd numbers. So 1, 3, 5, 7, right? Based on the TID it will take. Now, interesting part is the second. So this is the first parallel region. Then was the serial region, and then again a parallel region. And we set our A and X as thread private, right? If you remember. So uh, A and X should preserve their values as well as the copies across both the regions, right? So here, let's say if I had the value of A as 2, 1, 3, I mean 0, 1, 2, 3, then it should be same here, right? Which is matching, right? And value of B is 0 because it was not a thread private as well as it was private in our code, if you remember. And yeah, same goes for X as it was for A, right? X was again a thread private, and since it was thread private, its copy will be preserved as well as its value will be preserved across the parallel region. So whatever value was here, it should be same over here in the second parallel region. So that is what I'm trying to explain here. And this is the utility of thread private variable. I mean, setting the variable as thread private. Now, yeah, so now let us go back to our code quickly. I want to show something else. Yeah. So let us say that I do this thing. A and access private along with P and T ID. And again, here I do the same thing, right? So I'm setting A and access thread private along with them being private in each of the parallel regions. So now what will be the output for this program? Please try and try and work out this example as well. I'll wait here for a few seconds again.
So it might not let us compile since we've already defined ANX as thread private.
Yeah, anyone else who would like to comment? Yeah, so okay, if yeah, let us try to understand this as well. So okay, let me go back to my code screen. Okay, let me share my code screen. Sorry, not code screen, this console screen. Let us try compiling this. Yeah, so as you suggested, if people suggested, it is not allowing me to compile, and the reason is that you are setting same variable as private, and again, sorry, first you are setting it as thread private and then again private, so it is not allowing us to compile. So yeah, this point should be clear, right? You can either set a variable as private or thread private, and since you are setting it as thread private here, okay, let me go back. You are setting it as thread private here. It is by default ensuring that there will be a private copy for each thread, as well as these copies and as well as the values will be preserved across the multiple parallel regions, right? So this is not, I mean, this is the wrong syntax that we are doing here. So let me remove this. Now let us do this thing. Let me set A as 1 and then let me print it here. Now what will be the output for this line? Basically, what will be the value of A? Or let me even set the B as well. Then before. I think B is not needed. I think I'll set it for X. Now what will be the output for this line? Anyone would like to comment? Okay. Okay, then I'll add. So what I'm essentially trying to derive, the point that I'm trying to derive here is that I've set the value, I mean, I've declared obviously A and access thread private. Now I'm setting its value in the serial region, and then I'm trying to get its value in the parallel region. In this case, it's first parallel region. Then what value it should take? So should it take the values that are set here, or will it take the some undefined values? So will so basically the point is this: will the thread private behave like private, where it takes the value as undefined for A and X? For A and X, it takes undefined values like private, or does it act like a first private class, where whatever value is set here in the serial region, it will take those as the initial value. So that is what I'm trying to check here. So let us check it quickly. Let me share my console. Yeah. Okay, so it compiled and let me run. So what it is doing, sorry, what essentially it is doing here is that if you see, it is obviously it is printing 2 times now for each thread, because within the same, if you remember in our code, within the same parallel region, we were printing twice. So it is printing twice for each thread. That is okay. But if you see, the initial values are all zeros. So if you see for thread 1, it is printing 1, 1, and then 3, which is okay, which is for the second C out. I mean, the second printf that we were having. But for the first printf, initial one that it was having, it is taking all zeros. So from that, what we can conclude is that it is taking undefined values, right? We set a and x as 1 and 3. So it should take those, but it is not taking 1 and 3 here. It is taking undefined. So similarly for thread 2, right? It is taking all zeros apart from the second one, where 2 to 5 are the ones that we set with. So all zeros for here, for this one, I think the same. Okay, yeah, this one the same, and yeah, for all 4 we can see, right? It's all zeros for the initial printf that we wrote. So the point here is that Threadprivate is more like private clause when it comes to setting the initial, I mean, taking the initial value. So it will take the undefined values like the private. And we need to make sure that we set in the parallel region first before moving ahead. Okay, so this is one point that I wanted to add. Apart from that, if I can go back to the code. Yeah, so this is one. Now, let us come to this part, this last part of the code, right? And if you see this printf was printing the value of a, b, and x again. And if you remember, in the end, the value of a, b, and x that were printed, right? If I can share my console back, a, b, and x, the values were the one that were for the master thread. So 0, 0, 1, which were for the master thread. Now let us say that these values for the master thread that got printed here, if you want to, if you want this values to be copied to all other threads, right? So here, these are the values 0, 0, 1 for the master thread. If you want to copy it for all other threads, that is 1, 2, and 3, if you want to copy this values for all other threads, then so basically what you can do is that you can say you can use this clause. So let me go back to the code. Yeah, so you can say this, right? And you can only do this for thread private variable. So you can do this. You can use this clause, which is copying. So what copying clause ensures is that whatever was the values, whatever were the values for the thread private variable a and x, after execution of the last parallel region and the before beginning of this next parallel region, and if you have specified this copying, what it will ensure is that it will copy all the values from master thread. I mean, copy the values of the variable from master thread to all other threads. So here, since we have a and x as thread private, and we are copying, we are using copying here for a and x, whatever values were there for a and x in the master thread will be copied to all other threads before it starts executing this parallel region. So considering that all these things, keeping all these things in mind, what will be the output for this last or the third parallel region? So these are this one is our third parallel region, right? What will be the output for this third parallel region? Anyone?
So were we resetting the values of a and x in the main function?
No, right? We are not doing anything. We are just printing it here. We are not resetting it anywhere, if you see.
So
Within the
1
code.
and 3, right? So value of a and x then should be 1 and 3.
1 and 3. Okay, tell me one thing. So if you remember, let me go back to here. So this is the second parallel region, right, from our last execution. So which thread is the master thread here?
Thread 0.
Yeah, so thread 0 is the master
Okay.
thread, right? So it will copy all the values for the thread private variable for the master thread into all other threads. So
So
here
it should be 0 and 1.
it should be 0 and 1, right? Let me show that to you. So it's 0 and 1. B we are not worried about, right? B is anyways not thread private here. So whatever value, I mean, it will take some default value, something like that, the undefined value basically. So the main point here is that A and X are now 0 and 1. So whatever the value was there for the master thread, it is being copied to all other child threads, and that is what is the copying. And the thing here to note is that copying will only work for the thread private variables. So in this case, A and X were thread private. So we can specify copying for them and make the values consistent with the master thread. So that is what is the copying. So let me quickly switch back to the slides. So I think we almost covered every point that is written here. So we should use it immediately following the variable declaration, or let me go back to the code to show it more visually. So here we are using it just after the variable declaration, right? You see here. That is what is mentioned here in this slide. So immediately following the variable declaration, this is what this is how we generally use it. And yeah, it keeps the copy allocated for all the threads for all the parallel region, and it retains the values. And we saw the syntax, right? And yeah, dynamic threading has to be set to false. And coming to copying clause, it copies the values on the master thread to all other threads. And it can be only used with the thread private variables. So this is what I was mentioning, right? And this thing, I mean, this copying of values from master thread to all other threads begins at the, I mean, occurs at the beginning of the parallel region where we have specified the copy. So coming to our example here, it will begin here. So when OpenMP looks into this copying, it will copy at this point. It will copy the values from the master thread to all other threads for this thread private variables. So yeah, I think that is for copying. And yeah, the syntax we already saw, right? Hashtag moving the parallel followed by copying. And yeah, I think that's it. Okay, one thing I think we missed here. Okay, let me go back. Okay, yeah. Yeah, let me go back to our code. So syntax is clear, right? We saw this syntax and this is the set of variables. So yeah, the applicable directives are parallel. So let us try this. Maybe we can try this. So let us say that I do this thing, right? Can we do this? Let us try this. Will this one work? Anyone? Let us say that I remove copying. I just make this parallel, change this parallel to parallel for, and we print the same. Will this one work? So essentially, we are trying to test whether the this thread private variables are working with the parallel, sorry, parallel for directive or not. That is what we are checking. Okay, so let us quickly
So the
check this.
parallel
Yeah.
for clause has to be followed by for loop, doesn't it?
Yeah, so that is one thing, obviously. Yeah, so this one. Yeah, but let us assume that there is for. Let me write it quickly. One. Right? Let me write this quickly. So I just want to see if this one works also. I haven't worked out with this one, so I want to quickly see if this works. But anyone who knows, like, will this syntax work or not? I feel like this won't work, but anyone who would like to add. So essentially, we are trying to access the thread private variables within the parallel for region. And I want to see whether this is possible or not. So let us quickly check this. Let me go back to my console and run it. See, so it is giving error. Okay, I think this error is not related to S was not declared in this code. Let me fix this. Is there any S? Okay, yeah, I got it. Yeah, yes. And yeah, let me add this also. Maybe. Yeah, I've tried removing this one. So let me see if this works. For statement expected before this. Okay, I think this one isn't working because okay, let me share that on code screen, because it is saying that for statement expected before this token. But okay, anyone who is able to see any issues with this code, but I think that this one is correct, right? We aren't doing anything wrong with this syntax.
So the for loop has to be the for loop has to be followed by the parallel for statement. So that
Yeah, I
first
think
block shouldn't be
this is
there.
the one, right?
Yeah.
This is what we are doing. Anything odd that you can see? At least I'm not able to see anything that is odd. So I just wanted to try if we can use thread private variables within the parallel for, and it looks like we are not able to. So let me quickly check again if after removing this parentheses, we are able to do it. Let me quickly compile. Now it is compiling. So basically we can use it, right? So yeah, it is working with parallel for also, and yeah. So whether copying works, let me check that. Does copying works here? Let me remove this copying and yeah, let me add this. I think now we are not doing anything wrong syntactically. Let me see if this
So
works.
as long as the number of threads in the program remains the same, it should work, right?
Yeah, but we are not changing it right here. Are we? No, right? We are
No,
not.
sir. So
We have said
exactly,
that.
so it should work because the number of threads are going to be the same.
Yeah, so essentially that is what I want to check here. Like I haven't worked out with this, so I'm trying it on during the lecture. So I want to see if this is working. Yeah, it is working. So yeah, and it is giving the result. So yeah, essentially this is something new that even I was not aware of. So yeah, so essentially we can use this thread private variables within parallel for also, as long as we are not changing the number of threads, right? So and copying also. So I think I should update this thing here also, which I haven't done. So applicable directives are parallel as well as parallel for and for. So we can apply it for these three directives. And yeah, syntax part we have already seen. And yeah, it is applicable for thread private variables. And yeah, we should specify it within the start of the parallel region. Any questions, anything that you might have observed and would like to ask here? There is one more clause that I wanted to cover, but I think we are running out of time, or I think we should take it up in the next session. But yeah, I'll stop here for questions so that can get clarified. Any questions? If there are no, then I think I can we can go ahead with the last clause that I wanted to cover. Okay, if there are no questions, then let us look into this one as well. So last clause that I wanted to discuss was this copy private clause. So this copy private clause is basically used with this single clause, right, that we saw in the previous session. So what single ensures is that only one thread will execute the single section or the structured block of code that follows that single clause, right? And if you remember that there was this implicit barrier at the end of single, right? Okay, let me go back to the whiteboard to explain this. So let me pull this out. Yeah, so we were having this thing, right? The hash pragma OMP parallel, and this single will come inside the parallel, right? So we have some parallel region inside which we have hash pragma OMP single, and yeah, so here there might be, let's say, 4 threads that are being launched, and this parallel region is being executed by 4 threads, but we have the single region here, right? And we saw that, right? There will be only one thread that will execute the serial region, and there will be implicit barrier here. So here is where copy private clause comes in. So what it will ensure is that let us say that this each thread were having the private copy for some variable A, and we wanted to ensure that this copy is being I mean one thread, let's say one thread which is some thread within the single region is being updating this variable A to, let's say, some value 5, and we want to make sure that after this single region ends, each of this thread should have the consistent view of that variable A. So that can happen if we specify this variable A as copy private. And what copy private will do is that this variable A will the value of the variable A that is being set or being modified within this single region will be copied by whatever thread it is being modified. It will be copied back to all other threads. So let's say in this case T0, or let's say T1 modified it to 5, then all other threads will at the end of this single region, all other threads will see its value as 5. So for T1, sorry, for T0, T2, as well as T3, its value will be set to 5. So that is what is the copy private. So quickly going back to the slides. Yeah, so essentially it is used with the single clause, as we saw, and only one thread is allowed to execute the single clause, as we know. And what copy private does is that it specifies that one or more variables should be shared among all the threads. So after that single execution of that single clause is over, the whatever variable that we have specified in this copy private, like this syntax that we saw here, right? Those variables will be shared among all the threads. And yeah, we know this, right? That there is an implicit barrier at the end of the structured block of code that is followed by the single section. And yeah, the single section must be in the parallel region. So let us quickly walk out through one example so that we can get some clarity around this single as well. Single as well, this copy private. So yeah, let us look into this example. So I think this is very similar to what I just explained you in the whiteboard. So what is I mean, what this code will output is what my question is here. Yeah, so this is the last code for our session. Would like all of you to try out what will be the output here. So we have declared A here, and then we have done, I mean, we have used this Firstprivate, right? So each thread will have the private copy of A. Now, within that, we are using some barrier, and then we are using copy private, and then before that, we are printing A as well as thread ID. Then barrier, then using single section with copy private, and then printing value of A and thread ID again. So what will be the output? Anyone?
So for the first printf, the value of A should be 123 across all the threads, and
Yes.
within the execution of the single block, and following that, the value of A should be 456.
Okay. So tell me one thing: how many lines will be printed in the output? Considering that we are launching this parallel with 4 threads.
So
What would be the
9
number of
lines should get
lines?
printed.
Yes, that is correct. Now, yeah, that is correct, that 9 lines will be printed. And considering that first 4 lines are being printed by this printf, A should be 123, right? That is for sure, like, because we are doing nothing here. We are just setting A as 123 here, and then we are using Firstprivate, right? So Firstprivate will ensure that we are copying each and every value of, I mean, sorry, not each and every value, but whatever value of A is there here, we are copying it to each and every private copy of the thread after declaring the private copy. So here it should be, that thing should be clear, right? Here, each and every thread will print its thread ID, along with that it will print 123. After that, within this single, first of all, there is a barrier here. So what will happen is that each thread, after printing this thing, they'll wait here, right? They'll wait here for each thread to finish this statement. Once all the thread are here, they'll after each and every thread reaches here, only then all the threads will proceed, and one thread will execute this single section, within which that thread will set A to 456, and yeah, all other threads will be waiting here, right? Only one of the thread will be entering this region. All other threads will wait here at the end, because as we saw, right, there will be an implicit barrier at the end of single. So all other threads will wait here. One particular thread will set to 456, and it will print this, right? This thing, right? That thread with that thread ID executed single, and it changed A to 456. And after that, since we are using this copy private here, what will happen is that this value of A, which was being set within the single region to 456, will be copied to all other threads. So here, once this single region is being executed by any of the thread, I mean, any one thread within this scheme of threads, once that is done, the value of 456 that was being set by that one thread within its private copy will be broadcasted to all other threads. So all other threads within their private copy will get the value of 456. And then after this this printf should print the value of 456 for all the threads, right? So this is what is the subtle thing that you should note here. So if I try running this program, so let me share this. Right, if I try running this program, private.cpp, it is giving this 123 followed by this statement, as we saw here, thread 2 is setting it, and after that 456 for all the threads. Now let us say that I make this change. This will be the last one, but let me do this as well. Let me make this change. so that we can be more clear here. So let us say that I make this change, right? I remove this copy private. Now what should be the output? Anyone who want to quickly add? What will be the output for especially this printf? What will be the output?
So in the second printf, only one of the threads that executed the single block should have the value of as 456. The rest should have 123.
Yes. So let us confirm this understanding that we have with by running our code quickly. Right. So as you people mentioned, right, that only after the single is executed, only one thread will have AS 456. The one thread who is executing this single. So in this case, thread 1 is executing the single. So that thread is having AS 456. Rest all are having it as 123. So that is what is the point that I want to highlight. So yeah, with this, I think we are towards the end of our today's session. Any questions about, related to anything that we discussed today? Then please feel free to ask. I'll be there here for 2 more minutes, and yeah.